phase is 0, when it's 0, the current is 0. When it's 90 degree, the current is maxima. Then again next 180 degree it is 0. Then 270 degree maxima. Then 360 degree 0. So you will get two things you will get. One is maxima and 0. Okay, and another is maxima in opposite direction. So that is a definition for alternate current. So if you go for similar trend in the DC current. So DC current, instead of two phases, instead of a positive direction, two direction, only in current will be produced in the one direction. So then so that's first so where the DC current will be used, and what is where the AC current will be used. DC current will be used in the where the current is needed in the high power technology. No high voltage consumption. Where you can find very high voltage consumption, very high current consumption. Where you can find very high current consumption or very high voltage consumption. So because the voltage is what is voltage? The change in the voltage of one phase to another is a high voltage. So high current will lead to high voltage, low current will lead to low voltage. So where you feel that a high voltage technology is used, specifically they need only high voltage technology only, not low voltage. So in that case, where you will find high voltage technology, where you will go for low voltage technology. That's based upon the power. What is work done? Force into distance. That means if I need to produce more force, what I will need, what I have to do, I have to produce the more work. So more work I am producing here, so I have to produce more force. Here in a low current consumption, where comes the work done, same force into distance, low force, low work will give the low force. So based on this, now which will have a high current consumption in where the work has to be done the maxima, where the work to be done in the maxima. There the work so it will have a high work done or high voltage. So you need high voltage or high current, etc. Here comes the low voltage, low current, etc. So now comes where AC will be used, where DC will be used. DC is the direct current by which you can see only one phase. Okay. Here you can see alternating current, which is double phase. That is you can see that it's going in the upper and lower like that. But here it will be only in the upper direction, not in the lower direction. That is AC. The DC means you will have only DC means you will have only in the one direction, only in the upper direction, not in the lower direction. So current high voltage consumption is high voltage. DC is needed in the high voltage consumption. AC is needed in the low voltage consumption.
AC for low voltage, DC for
high voltage. So where now then in that case where high voltage consumption, where you need the high voltage consumption. There nuclear electricity is produced, where you need to work done. Train, railway, engine is attached to how many compartment? 14 or 15 compartment. One compartment can accommodate how many people? One compartment can accommodate almost 100 people. So 100 into 10 compartment, 1000 people. So train engine. So in all railways they use only DC current. Low energy consumption. Low energy consumption is home appliances like our houses they use the low energy, which is energy consumption is very low. So which current they will use in house? AC current. In train?
DC current.
DC current. So that's why you can see, you can find plenty of transformer in every street, right? In your house, surrounding your house, every 10th street you will find every transformer. What is meant for the transformer? What is meant for the transformer? To pass the current. Huh? To supply, no, current, that is not, that will not supply the current. Transformer will not supply the current. You are producing, we are producing in power, three types of production is there. One is coal production, that is in Ennur. Then nuclear power production, that is in Kalpakam. Then hydroelectric production is there, where from the dam, you know, right, when you open the dam, what will happen? Water will flow, and water will flow. Now they will open by mid-June, June 12th they will Mettur Dam. Mettur Dam every year they will open June 12th. So what will happen after June 12th? June 12th, 13, 14, 15, 16, what will happen? Before that they will not open the dam. They will open the dam only on June 12th. That's constant. Every year to June 12th they will open the Mettur Dam. Then June 12th, 13, 14, 15, what will happen? When the dam is open, what will happen? When the dam is open, water will flow. When the water will flow, if we keep a blade to it, what will happen? Due to the force, water is flowing, the blade will rotate. When it rotated, so when something is rotated, when any fan is rotated, it will connect it to the, it will connect to the, so from that the electricity will be produced. So that is one way of producing, that is hydroelectric power. That is hydroelectric power, because what is produced, current is produced from the current is produced from the flow of water. So it is called as a hydroelectric power. The power is produced from the nuclear power plant is nuclear electric power. The produce Ennur, you know Ennur? Ennur. It is you know Thiruvattiur, you know beach, not beach, Marina beach. You know Thiruvattiur?
No, sir.
You know Ennur? You know Central Station? Yeah, no, not Ennur. You know at least Central Station?
Yes.
Central Railway Station, you know? You know, right? Central Railway Station. From Central Railway Station, I think hardly 5 kilometers, not 10 kilometers you can keep. You will get Ennur. There it is, the thermal power plant is there. From there only, not heavy, it's a light one, so we are producing from the coal. We are having plenty in all over Tamil Nadu. One is located in Chennai, which is in Ennur. So that is produced from the coal. What will happen from the, how will you produce from the coal? Electricity? Coal will heat the water. When the water is heated, what will happen? It will be converted into liquid to vapor. Hot vapor, then they will get the turbine. Okay, when the hot vapor flow through the turbine, what will happen? Fan will try to rotate. So when the fan try to rotate, from that you will produce the current. That's all. So this is a similar technique where the fan is rotating here. Here we switch on this, when one moment switch on, the fan is rotating. That means what you are supplying the electricity to rotate the fan, which is we need the so we are supplying the electricity. So if the fan rotates automatically, what will happen? From that we can produce the reverse of it. So from the fan rotate, what will happen? You will produce the no, when fan rotates, what will happen? Electricity will be produced. The reverse of this technology is that technology. That's all. No, we are seeing AC, no? AC, DC. What is purpose of transformer? You didn't tell that. Production of electricity is from nuclear power plant, hydrothermal power plant, thermal power plant, hydroelectric power, then nuclear power plant. What is purpose of transformer? What is? Transformer electricity is the one will step down the high voltage to the low voltage. We in a home we need a high voltage, no low voltage. But what they will send is a high voltage. So the transformer will step down the high voltage to the low voltage. And there is a transformer where we can step up, where the low voltage will convert it into high voltage. So that what type of transformer that you will find in the street here? What types of transformer you will find in the street? What type? What is the purpose of transformer?
High voltage and low voltage.
High voltage it converted into low voltage. So it is a step down transformer. Step down transformer. When it converts the low voltage to the high voltage, it is a step up transformer. That's all. So first one you're going to see AC voltage applied to the resistor. When the AC voltage is applied to the resistor, what will happen? First one is V is equal to IR. Now V can be written as Vm into sin omega t. Okay? So V is equal to sin omega t. So if then Im is equal to since Im is equal to Vm by R, I is equal to Im sin omega t. Okay? So the final value we obtained is the root mean square or I is equal to Vm is equal to Im by R, Im into R. Did you get this equation? Vm is equal to Im into R. V is equal to IR. V is equal to IR. You got it. So this Vm is equal to IR or V is equal to IR. Or no, Vm is equal to IMR means what? Vm is equal to IMR means what? Maximum current. Everything you are blinking. Why you are blinking everything? The maximum voltage that is obtained, for that you will get the maximum current. So Vm is equal to IMR. Then the similar trend, the voltage applied across the inductor. Okay. So in the inductor, voltage is equal to L into di by dt. So V is equal to, what is V? No, just listen. V is equal to L di by dt. V is voltage. Di by dt is rate of change of current. What is L? L is the
Inductive reactance.
not inductive. No, not inductive reactance. Inductive constant.
Reactant is a constant.
Reactive is a constant.
Yes, sir.
So then finally amplitude of current is given by Im is equal to Vm by XL. Then PL is equal to IV, which is Im sin omega t by pi by 2 minus into Vm sin omega t. Okay? Did you get this equation? Huh? Which equation I gave for a? Huh?
For inductance, XL equal to omega L.
XL is equal to?
Omega L.
XL is equal to omega. No, that's the inductive reactance. XL is
Inductive reactance.
inductive reactance. What is L here?
Inductive.
Mutual, inductive constant or mutual inductive constant. Mutual inductive constant. Okay. Now in a similar scenario, now we go for AC voltage applied across the capacitor. The capacitor, okay. Capacitor voltage is V is equal to Q by C. V is equal to Q by C. Okay. No, this is general statement. This is general statement. Q is equal to V is equal to Q by C. That is, V is voltage, Q is a charge, C is a capacitance. So did I give this equation? PC is equal to Im by Vm, Im into Vm divided by 2 sin 2 omega t.
Yes, sir.
What is PC here? Power supplied to the capacitor. Vm Im is maximum current, maximum voltage, and sin omega t, sin 2 omega t. Now now we have seen how many things we have seen? Inductance,
Resistance, induction,
capacitor. Now we are connecting everything in the one circuit. That is called LCR circuit. LCR circuit. So in the LCR circuit it tells that that the phase LCR circuit, how many did it give? Phase diagram and analytical solution. Phase diagram and analytical solution. In phase diagram, what equation I give?
IM equal to VM divided by
Root of r square plus x square minus xl whole square. So that is V. What is IM is equal? What is IM? You know, maximum current. VM is maximum voltage. R is the resistance. XL is the XL and XC. What is XL and XC? XL. Inductive capacitance. XC is inductive capacitance. XL is inductive inductance. Okay. In analytical solution, what I give? Nothing.
I equal to IM sin omega
By phi. I is equal to current. IM is equal to maximum current. Omega t plus phi. Phi is
magnetic.
no, not magnetic t. Change of the current. Phi is the angle between the phi is the not magnetic. That phi is different from this phi. I didn't tell you that this point.
No,
Phi.
No, sir.
That phi is different. That is a magnetic flux. So you thought that this is also magnetic flux. This phi is different. This is the angle between the current and the voltage. Angle between the current and voltage. Resonance. Okay. Resonance. Okay. The phenomenon of resonance is common among the systems that have a tendency to oscillate at particular frequency. That is, if you bring what the instrument is oscillating, if you bring some external force, that frequency and this frequency should coincide. That is the oscillator. That is the resonance. Okay. I give definition, no? Okay. So what is I give? Omega 0 is equal to root of LC. Okay. So what is L? What is omega 0? What is omega 0? Angular frequency is equal to root of LC. What is L and what is C? Inductive? No. What is L? Inductance. Yeah, L is inductance, C is capacitance. Then power factor. Did I give power factor? Power factor. Huh?
Application of resonance. Sir, application of resonance. Validity factor.
Yeah, no, application of resonance, what application I give? The TV antenna.
Yes, sir.
TV antenna. That is application is the antenna of radio signal from broadcasting. So you have you will be having plenty of you want to go to specifically Sun TV. So you turned on the television, you got the Sun TV, but there are thousands of channels available, thousands of radar available. So this is application of the resonance. So this channel should coincide with the vibration of the Sun TV frequency. Both the frequency should coincide. So that is a resonance, so that you will clear here the picture. If it is not coincide, what will happen to the picture? It will blur. It will show some blur images. Then what is next? Power in AC circuit. Power in AC circuit is given by P is equal to I square Z cos phi. Okay. Phi. What is phi? Phi is the angle between the current and voltage. In that, so the three cases arises. Angle between, did I told this? Did I tell this? 4 cases. 4 cases is resistivity circuit. Power is given by I square Z cos phi, okay, cos phi, okay. In that resistivity circuit is given by phi is equal to 0 means cos phi is equal to 1. So cos phi is equal to 1 means what will happen? P is equal to I square is at 1, which is maximum power consumption. Phi is equal to 0. Phi is equal to 0 means what is phi? Angle between current and voltage. If the angle between the current and voltage is 0 means what will happen? Huh? No, angle between current and 0 is phi is 0. That means what? You understand my question? First one is case 1. Case 1 is resistivity circuit. Case 2 is capacity circuit. Case 3 is LCR circuit. 4 is resonance in LCR. Okay? 4 cases is there. Did you take this? Did I told this or not? I didn't tell. Okay, 4 cases is there. 4 cases is there. First one is resistivity circuit. Resistivity circuit. Okay? Second one is capacity circuit. Resistivity circuit. Second one is capacity circuit. Third one is LCR circuit. Okay? Fourth is resonance in the LCR circuit. Resonance in the LCR circuit. First one is resistivity circuit. Second is capacity circuit. Resistivity circuit. LCR circuit. Third is fourth is resonance in the LCR circuit. Okay. Now go for first one. First one is resistivity circuit. In the resistivity circuit, phi is equal to 0. Phi is equal to 0 means cos phi is equal to 1. So what you mean that? What is phi? That's my question. That's all. If you understand this, you understood everything. Phi. What is phi? No, angle 0. Phi is equal to 0. If I substitute 0 in cos phi is equal to 0 means 1. So P is equal to I square Z cos phi. So P is equal to I square Z into 1. So P is equal to I square Z. Okay? Okay? This is the given value. I am asking what you understand means cos phi is equal to 0. That is my question.
Current and voltage is 0.
Current and voltage. If current is 0 means what is phi? Angle between the current and voltage is angle between the current and voltage is phi. Phi is equal to 0. If current is 0 means how will current will flow?
Current will not flow.
Current?
Will not.
That means you didn't understand anything from this. Phi is what is that?
Angle between
Current and flow. If you put I is equal to phi, current will not flow means I is equal to 0. No.
But I didn't understand, sir.
Phi is angle between current I and voltage I and V. Okay. Now I am telling that phi is equal to 0. Phi is equal to 0 means so I have to separate cos 0. Cos 0 is 1. So P is equal to I square Z into 1. So is equal to P I square Z. So P is equal to I square Z is a maximum value. If when it will be the maximum value, when phi is equal to 0, that means what? That's my question. That's all. What do you mean by phi is equal to 0?
Current and voltage are parallel. Or constant as the current is constant.
Both are traveling the same line. That's all. Angle between this is the angle. What is this angle between this?
Pi.
Angle. What is angle between this?
90 degree.
90 degree. What is angle between these now? 0, that's all. That means this is
Travel in the
same line, that's all. That is a phi. That is, if they travel in the same line, the power obtained will be in the maximum. If it is opposite means it will be less. So when it is maximum, did you understand or not the question? So P is equal to I square Z cos phi. Now you have to substitute cos phi is equal to 90 degree. Cos 90 is 1. Cos 90 is 1. So P is equal to I square Z cos phi. Cos 1. No, 1. P is equal to I square Z 1. So P is equal to I square Z. P is equal to I square Z. Okay? Did you understand this flow?
Yes.
You will understand this flow. That's all. The current and in phase. That only they will tell in phase. That means current and voltage are traveling the same phase. Same phase. Same phase means the angle between them is 0. That's all. If the angle between the 90 degree means what? How it will look like? This is 90. So the current, if this current is like this, means voltage is travel like this. That is 90 degree difference. If in second case is capacitive capacitive circuit. So capacitive circuit means voltage and travel will perpendicular. Voltage and current will travel perpendicular. So perpendicular means how much I have to write? Cos 90 or cos pi by 2. Anything you can take. Cos 90 or cos pi by 2. Cos 90 or cos pi by 2. So cos 90 or cos pi by 2 is 0. Cos 90 is 0. So cos 90 is 0 means power is equal to 0, that's all. So there it's maximum current, here when it travel perpendicular it is 0. Then fourth option. Third option, LCR circuit. In third LCR circuit, phi is equal to tan inverse. Phi is equal to tan inverse XC minus XL by R. Phi is equal to tan inverse XC minus XL by R. XC minus XL by R. Then fourth case, resonance. Resonance phi is equal to 0. So cos phi is 1. So P is equal to I square Z, which is I square Z. I square Z into 1, which is P is equal to I square Z. So why phi is equal to 0 here? Why is phi is equal to 0 here?
Voltage and current travel in the same line, under the same phase.
No, in the resonance, XC minus XL is equal to 0. XC minus XL is equal to 0. XC in resonance, XC minus XL is equal to 0. So X is 0. So phi is equal to 0. Phi is equal to 0 means cos phi is cos 0. Phi is equal to 0 means cos 0. Cos 0 is 1. So if you substitute this value, P is equal to I square Z 1. So P is equal to I square Z. So the the power is maximum when at the resonance. So at the resonance, the power is maximum. So at the resonance, power is maximum. So how many things we have seen? We have seen resistivity, capacitivity, LCR and LCR and resistance. So for resistivity, what is the power maximum? Maximum power? I square is that first one. For second one?
0.
Second one is 0. Third one, tan inverse XC minus XL divided by R. Then fourth one?
Maximum.
Power is maximum. I square is that. Power in? Power in, power is over. Power in AC circuit is over. Next is? LC oscillation. So what is LC oscillation? LC means inductance and capacitance. So the inductance and capacitance the inductance LC oscillation, inductance and capacitance. So it is given by, what is the equation I gave? I is equal to Im sin omega t. Im is equal to omega 0 Qm. Im is equal to omega 0 Qm. Omega 0 is the, what is the omega 0? Is omega 0? Angular frequency. Qm is the maximum charge. Angular frequency and Qm is the maximum charge. Okay, what is next is? Did I give this a mechanical property? Mass, for it is mass it is m, for inductance it is L, force constant K, reciprocal of capacitance 1 by C, displacement is x, charge is q, velocity is equal to dx by dt, current is dx by dt. That is the velocity, what we are referring here, velocity, something moved from this, something is moved. What is the displacement? Displacement is a displacement by time, is a mass, some mass m you have to take, travel. That is from here, from Kodambakam railway station to Mambalam railway station. I am traveling with the train. So that what is my mass? My mass. Did you understand my mass? 50. No, yeah, okay. 100 kilometer you can keep. 100. My mass is 100 kilometer. I am traveling from Kodambakam railway station to Mambalam railway station. So what will be the distance? It will be approximately approximately 1 kilometer. So what is the time taken in the train, not by walk? If the time taken, what will be? 1 minute. 1 minute you can keep. So the distance is 1 kilometer. Time is 1 minute. So the what is 1 divided by 1? It will be 1. So 1 meter per second. So I have traveled 1 meter per second. So in the similar way, what is traveled in the current? What is traveled in the current? What is current? I. What is, no, I is a denomination. What is current? Flow of electrons. So what is traveled in the current? Yeah, electron is traveled. What they're telling is, we can take any example with the linear displacement. In a similar way, if you go for current means how it is related. How it is related. So like that, so I am traveling here from from Kodambakam railway station to Mambalam railway station. So similarly, current is traveling. If the current is there, means what will travel? Mass. So what is it then? What is the which mass you will take consider now in current? Mass of electron you have to take, which is etc. Mass of the electron you have to take. Then how the distance is travel. So with respect to time t, how it is traveled. So that only you have to take. So that's why it's given as velocity is v is equal to dx by dt, where current is equal to dq by dt. So here comes current is, what is the charge? Which charge? Q. You know what? Which charge? Negative charge. Negative charge of electron. Then mechanical energy. Mechanical energy is given by half k square plus half mv square. What is half k square? Potential energy. plus half mv square. Half mv is the kinetic energy. So this is kinetic energy of anything. I am traveling here, my kinetic energy half mv square. So what you will substitute this here? Half mv square.
Mass of the
No. What you will substitute in? I am traveling. I am traveling from Kodambagam railway station to Mambalam railway station. Distance is 1 kilometer. Time is 1 minute. So v is equal to dx by dt. So what is v is equal to now? 1 meter per 1 second. No. 1 meter. 1 meter. No. What is the distance? 1 kilometer per distance. So 1000. You have to convert means 1000 meter per second. From 1 kilometer. It will be roughly 1 kilometer. Kodambagam railway station to Mambaram railway station will be roughly 1 kilometer. So 1 kilometer, 1 kilometer per second or 1000 meter per second. Now let us assume, now you are taking your, you are substituting this value E is equal to half kx square plus half mv square. So what is mass of what is my mass? What you will substitute for mass here? Or okay, 50 or 100, something approximately 100 kg. So 100 kg, v square is distance travelled, which is 1000 meter per second. Then you go for here potential energy. Potential energy is half k x square. X is displacement. That is distance. What is the distance that I travelled?
1 kilometer.
1 kilometer or 1000 meters. Okay. F is force constant. That is constant value. F is force constant value. Now in the similar way, if you go for here, what it will substitute? Electromagnetic energy U is equal to half q square by c. Q square is the charge of electron. C is the capacitance. Then half Li square. What is L?
Inductance.
Inductance. I is current. That's all, current. So they are correlating, simple. If you take some mass, you can take any mass in the linear motion. That is I am traveling. That my traveling itself you can take. I am traveling from Mambalam to Kodambagam to Mambalam railway station. So a person is traveling. If you calculate for a similar way, you can calculate for electron. Electron is what is the mass? You have to know that mass. You have to know its velocity, everything. So if you if you're able to calculate it, what you can do, you can calculate this total energy. Total energy. Now transformer. Transformer is given by I already told what is step down and step up. That is Vs by Vp is equal to Ns by Np. What is Vs? What is Vs? Voltage across secondary coil. Then Vp is voltage across primary coil, and Ns is number of turns in the secondary coil. Np is number of turns in the primary coil. For step down transformer we will have Np is greater than N. What is another information I give? That's all, no? Is is equal to Np by Ns into Ip. Okay. So what is Is? Current of secondary coil, and Ip is current of primary coil. Then Np by Ns, number of turns in the primary coil, number of turns in the secondary coil. So if that case, we want a step down for transformer. The step down means Np is greater than Ns. That means what? Np is greater than Ns. What is Np?
Primary coil is
Number of turns in the primary coil is greater than the number of turns in the secondary coil, will constitute the step down transformer. Step down transformer. What is step down transformer? I already explained to you.
increase in voltage.
No, step down.
Step down high voltage to low voltage.
High voltage to low voltage. That is a step down. For that, what is the criteria now? Okay, right. Transformer are two types. Which is step down and step up and step down. Okay, for step down it is Np is greater than Ns. Np is greater than Ns. For then step up it should be NS is greater than NP. That's all right?
Yes.
That's all.